The purpose of this laboratory experiment is to examine the effect of pipe size on efflux time from an open tank. First, the tank diameter and other relevant dimensions were measured. A schematic diagram can be seen in Figure 1. The tank was filled with water and it was allowed to flow freely until a certain point was reached before a vortex formed. That time was recorded. The same procedure was done 5 times and the highest and lowest measurement was discarded and the remaining were averaged. Here you can see the experiment being done with a pipe that has a diameter of 3/16 of an inch and a length of 6 inches. The final water level inside the tank was stopped before it was too low to avoid the formation of a strong vortex which may affect the drainage time. The procedure was repeated for a constant diameter of 3/16 of an inch and varying lengths of 12 inches and 24 inches. And it was also repeated for a constant length of 24 inches with varying diameters of 3/25 of an inch, 3/16 of an inch, and 5/16 of an inch. Here are some important equations for average flow velocity in a pipe. For given values of H, L, and D, equations 2 and 3 can be solved for V as a function of F. The procedure is to assume a reasonable value of F, solve for V, calculate the Reynolds number, and from Moody diagram, obtain a new value of F. Values of F for tests using water at room temperature with average head of 0.6 foot are seen in Figure 2. This equation shows the time interval for the water level in the tank to fall from H1 to H2 after integration. From here, the predicted value of the effect of pipe diameter and the effect of pipe length on efflux time may be determined. Our results can be seen in Table 1 and 2. Based on the data gathered from doing the experiment, an increase in the diameter of the pipe caused a decrease in the time it took for the tank to drain with equal amounts of water. Also, a decrease in the length of the pipe while keeping the diameter of the pipe constant also caused an increase in time, but only by a few seconds. Differences in the predicted and measured times could be due to inconsistencies when starting the stopwatch with the flow, getting F from the Moody diagram, errors associated with kinetic energy and alpha, or other human errors.
Is that